Okay, hello everyone. Welcome to National Astronomy Week. And today's theme is robots on Mars. I'm going to be your host this evening. My name is Emily Drabeck-Maunder. I'm one of the astronomers at the Royal Observatory in Greenwich, and I'm also the Senior Manager of Public Astronomy there. Now, co-hosting for me tonight is Nigel Henbest. Would you like to introduce yourself, Nigel?
I'd love to. Thank you, Emily. I'm delighted to be co-hosting this National Astronomy Week event because I was actually the chair of National Astronomy Week back in 1990 when we spearheaded the campaign against light pollution here in the UK. As well as being an astronomer, I'm also signed up with Virgin Galactic as a future astronaut. So I'm particularly interested in hearing the behind-the-scenes stories of the robotic space missions going to Mars tonight.
Absolutely. Now, I think one of my favorite topics in regards to Mars is the robots that it has on its surface. So it's going to be a really exciting night tonight. Now, for the next hour, we're going to have two talks on the rovers, orbiters, and landers that have been sent to Mars, and specifically why they've been sent to the Red Planet and what they've been able to find so far. Now, after each talk, we will have some time for questions and answers with the speakers. So please send your questions to us using the Q&A button at the bottom of your screens. And actually, after both of the talks, we'll have a bit more time for a question and answer session as well. Now, our first speaker is actually Professor Sanjeev Gupta, a planetary geologist at Imperial College London. So at this point, I'm going to hand over to Sanjeev to get started with the first talk.
Hi, welcome. Thanks very much for having me here. So let me just bring my slides up. I'm very excited to talk to you about Mars. So let's get our slides up and tell you about what's happening on Mars. So this absolutely beautiful image is a picture taken in July earlier this year of our latest rover, the latest NASA rover on its way to Mars. It's the Perseverance rover. Towards the end of my talk, I'm going to come and talk about what that rover is going to be doing. It's going to be landing on Mars in February of 2021, February the 18th, and it's going to start off a whole array of Mars exploration that's really, really exciting. But let's first turn our attention to the active rover on Mars at the moment. So this is a beautiful image taken by the Curiosity rover in Gale Crater. And you can see this fantastic landscape in front of us of these beautiful rocks in Gale Crater that form part of Mount Sharp. And what we as scientists on the rover mission are interested in is reconstructing what these rocks represent in terms of the ancient landscape of Mars. What were the ancient environments of Mars like? Was it warm and wet? Was it cold and dry? Was it a desert with no evidence for life? And Curiosity isn't a life discovery mission, but it's trying to find out whether the conditions were right for life to have formed and flourished in. And then future missions will go and actually search for life or try to bring samples back, which I'll come on to in a minute. So currently the Martian atmosphere is very, very thin and long-lasting surface water is no longer possible. So we don't have active rivers and lakes and seas on Mars. It's a cold desert. But almost 100 years ago, people actually thought there were civilizations living on Mars. So this is an incredible headline from the New York Times from 1911. Martians build 2 immense canals in 2 years. Well, by the 1920s, 30s, this was shown to have been false. And it wasn't until the Mariner 9 mission that we actually discovered evidence that there had been surface water flow. People thought there was surface water flow. They imaged these beautiful canyon systems, but these were dry. And so they represented a time in ancient Mars that perhaps water had flowed in. And there's even suggestions that Mars had oceans on the surface. And what missions since then have been doing is trying to fine-tune our understanding. So it's always a question of, oh, NASA discovers water again, but we want to get the details of that. So that's not a cat on Mars, that's my neighbor cat, but Curiosity landed in Gale Crater, which is shown in the white box. Those of you who've seen the movie The Martian, that's where Matt Damon landed and probably still is. And Curiosity landed in Gale Crater. So you can see the landing ellipse, and in the center of Gale Crater, there's this mountain called Mount Sharp, which is made up of stratified layers of rocks. And people thought that those layers might be sedimentary. And we look for sedimentary rocks to search for ancient environments which might have harbored ancient microbial life. And this is what Mount Sharp looks like. This is a beautiful image taken by the Marscam cameras on Curiosity. Note that the Martian sky is not blue. These are color stretched images because we want to get out the details for us to look at the geology, basically look at what the different rock types are. If you see them in raw color, everything looks red basically. So these are stretched colors, and you can see the dark areas are modern sand dunes. And these areas over here are the interesting rocks that we want to explore and look for. In particular, these areas, these rocks over here are full of clay-rich minerals that are very good at trapping organic matter. So this is a very recent selfie taken by the Curiosity rover very, very recently. The rover is very, very narcissistic. It spends a lot of its time taking pictures of itself. But we get these fantastic pictures every time. We take these fantastic pictures every time we actually drill holes in the Martian surface to look at the chemistry of the rocks here. And this is a picture taken at Rover Operations Center at the Jet Propulsion Laboratory. This was actually taken when we were on early days of the mission. At the moment, everybody is actually working remotely, and it's actually quite remarkable that Curiosity is being operated entirely remotely by people working from their homes, making things happen, basically. Quite an extraordinary engineering feat in itself. So Curiosity landed up here, and we've been driving since then all the way to get to the lower slopes of Mount Sharp, which are over here. And we're actually located currently somewhere in here. So we've done a huge part of the mission over here, and we've driven almost just over 20 kilometers. And we're getting to these very interesting geological transitions over here. So we've been exploring what we call the clay unit at the moment, and we're getting to what we call the sulfate unit very, very soon. And we have no idea what that sulfate unit represents. Here's just some of the beautiful mosaics that the cameras take, and I'm not going to go into detail in this, but these rocks that you can see in the foreground, we think that those represent ancient river and delta deposits representing running water on the surface. And we're looking towards Mount Sharp, and when we encountered these rocks, we noticed that the currents indicated by these rocks in Mars's ancient past were actually flowing towards the center of the crater. And we predicted that the water would actually pond in this part over here where we see Mount Sharp currently. When we got to these areas further downstream in the ancient times, we discovered these light-toned rocks, and even with this image, we have no idea what these rocks represent. But as we got closer and closer and were able to deploy the arm instruments, we could see that these rocks were actually very, very fine-grained. You can see a beautiful picture, and they're beautifully laminated. So you can see these laminations are about a millimeter, several millimeters thick, and we see these repeated laminations. And as a geologist, looking at similar rocks on Earth, we interpret these rocks as having formed in ancient lakes. So these are layers deposited by sediments carried by rivers, which abruptly slow when they reach a standing body of water, and we get deposition taking place. And so we get these multiple cycles, maybe multiple flood flows or whatever from rivers entering a standing body of water. We wouldn't expect rocks like this forming from airfall, for example. So we interpret these rocks as they're fine-grained rocks, and we interpret these rocks as mudstones. And now we've driven through almost 200 to 300 meters thick succession of these rocks. And so it suggests that there were long-lasting lakes which were wet, sometimes dried up, and then came back again. And the water likely came from rainfall or snowfall that melted on the crater rim and entered Gale Crater. We've been drilling consistently, and you can see all these drill holes, and you can see they have different colors, and they represent different chemistry of the rocks. So different minerals in the rocks with different chemistries. And what's very interesting is, whilst the rocks themselves haven't changed that much in terms of those mudstones, those lake mudstones, the chemistry has changed. And that could be due to changes in the lake water chemistry or due to later alteration. And that's a really interesting puzzle that we're trying to work out. And this is where we are at the moment. We're in a place that we call Glen Torridon. The rocks that you can see in the foreground are all clay-rich minerals, and we're exploring these rocks and trying to understand the chemistry of these rocks, and also be able to tell something about whether they contain organics within them. We have discovered organics in mudstones on Mars, and we're trying to explore this in even more detail. And next up, this is Glen Torridon over here. Next up, this is the drive path. So we're kind of over here somewhere, and we're driving onto this. And the next few years will see us driving to the sulfates over here, and then heading up the hill. Who knows how far we'll get, up onto the lower slopes of Mount Sharp. We'll never get to the top of Mount Sharp, just the lower slopes, but there's lots of interesting geology here. And we have no idea what the environments represented by these rocks are. So it's really exciting to think ahead and have this journey of discovery, basically. So this is just a picture looking at Mount Sharp and looking at what lies ahead of us. So let's turn to the Perseverance rover, Mars 2020 rover that's landing in February. And the mission objectives here are different. It's obviously geological exploration to look at ancient environments on Mars from about 3.9 billion years ago, to look for signs of habitability. Was it habitable, and are there biosignatures? Is there evidence for life? And then most importantly, it's to prepare a returnable cache. So this is part of what's called Mars sample return. This is the first stage, and John will perhaps talk about this in a bit more detail. But Perseverance has the capability to collect 40 samples and blanks, to collect samples from a wide variety of geological diversity, which will be left on the surface of Mars and eventually brought back to Earth, and also to prepare for human exploration. So this is the Perseverance rover. It looks very, very similar to the Curiosity rover. It's on the same model, but has a whole new set of instruments that I'll talk about very quickly, only some of the instruments. So firstly, this is the Mastcam Z camera. I'm on the science team of the Mastcam Z camera. This is what takes those beautiful panoramas. But this is a step up from Curiosity in that these are zoomable cameras, and we're going to get amazing panoramas of the landscape in Jezero Crater. We have SuperCam, which is a laser which makes remote laser spectrometer measurements of the fine-scale mineralogy and chemistry. And we have Sherlock, which looks for, uses Raman to look for Raman and fluorescence spectrometry to look for evidence for organics and mineralogy, and also has a camera, what you can see over here, that takes really high resolution images of the Martian rocks. And most importantly, we have a whole new arm system with a turret, with a whole new drilling system and sample caching system. So you can see this arm over here that is going to core into the Martian surface, gather those cores and safely store them. And so that's just an amazing engineering feat. And you can see here's the turret over here, the coring system with the coring bits. And here we have the sample tubes being prepared. And here's the whole caching system here. Really, really complicated. I don't have time to talk about them, but we have the sample tube storage assembly here, which will then be left on the surface of Mars for a future mission to return. And perhaps John will talk about that. So the Perseverance is actually going to land over here. You can see the Curiosity landing site over here. This is where Perseverance is going to land. It's at the edge of the Isidis impact basin that formed 3.9 billion years ago, and we're landing in what's called Jezero Crater. And this is Jezero Crater. It's a small crater, and what you can see is that the crater has an inlet, a river channel going into the crater, and an outlet channel going out of it. So people think that this was once a lake, and that's what we're going to test is we're going to an ancient Martian lake. And lake deposits are excellent targets for astrobiology to look for evidence for life. And so the team has been very, very busy and characterizing the geology of the crater. And so this is a very simple geological map just showing you the diversity of features in here. And what we're going to be doing is sampling these different geological units and building up, and this is just a potential example of a cache of samples, a collection of samples. So for example, we might collect 3 lake deposit samples that when brought back to Earth, we can look for organic sample in and evidence for life. We might collect 2 samples of a unit that some people think is a basalt, a lava flow, that we might be able to age date once we bring back those samples to Earth. And that's something that geologists really want to do, is to get precise age dates for Martian rocks, basically. So that's what we hopefully have by 2030 back on Earth, to be able to be analysed in Earth laboratories at really fine scale and really delve into enormous detail into that early history of Mars. And what's really exciting is that Mars has abundant rocks from the earliest time of terrestrial planet formation, rocks that we don't actually have on Earth because they've been destroyed by plate tectonics. So Mars is actually a place to go to not only search for life on another planet, but also to actually understand what early Earth might have looked like, because those rocks on Mars might actually record what Earth might have been like in its early history that we don't have preserved on Mars. So it's remarkable to think that here's a picture from the 16th century, shortly after Huygens' observations with a telescope of Mars, that we can now actually be on this planet and be able to see features of a millimeter scale on the surface of this planet. Thank you.
Great. Thank you very much, Sanjeev, for your excellent talk. So we do have a few questions coming in. And I just want to say, actually, that a lot of what we found out about Mars so far is really fascinating. And I particularly love it that the Curiosity rover, for example, can actually flip a camera around and take a picture of itself. It's such a human sort of trait that it can do. So I think that's really fantastic. Okay, now a few of the questions coming in. So would you be excited if you ever had the opportunity of studying a core sample of Mars?
Oh yes, that's what we all want. The geologists, I'm a geologist, I'm an Earth geologist by training. And it's really only when we actually have a physical sample that we can get to the nitty gritty of it all. So for me, it's a little bit frustrating that I can't actually touch these rocks. And in fact, one of the most fundamental things that geologists on Earth do is actually they slice rocks and look at them down a microscope, and we can't actually do that with Curiosity. So some of those big questions that we can't actually answer about these Mars sedimentary rocks, we could actually answer very, very simply if we had a sample on Earth. So I think it's getting those samples back to Earth is just going to be a game changer for understanding Mars's geological evolution.
And I think that's a really kind of big technological feat of sending something to Mars that can then bring a sample back to us. That's incredibly difficult to do, but it would, as you say, be incredibly exciting to do as well. Okay, next question. We have, do you think that the water on Mars was there from the formation of the planet, or was it delivered over a long period of time by comets and asteroids?
Ooh, I think the jury's out on that. We don't really know. And I think that's also not my expertise. Putting my hand up here, there's things one doesn't know. I think that's a question that will be answered when we have samples back, basically. I think the thing is that the instrumentation we have on the rover can't actually address that sort of question. So we need to have information on the isotopes, etc. And so once we have those samples back, that's the sort of thing that we'll be able to address in detail.
Great, okay. And do you know how many robots and machines are actually active on Mars right now?
Okay, so we have Curiosity, obviously, we have the InSight lander, and then we have a whole bunch of orbiters, basically. So I can't remember all the names of all of them. So lots of active orbiters that are very nice because they relay the data we collect back to Earth. We need those orbiters, but we have InSight and Curiosity at the moment.
Great. Now, it's really amazing to think that there's a planet out there that's entirely inhabited by peaceful robots, but that's definitely a way to describe Mars. Okay, so some more questions then that we have. Given the development of robots which don't endanger human life and are cheaper, do we need a manned mission to Mars?
That's a question I often get, and that's very interesting. I think there are real physical limitations of robots in terms of geologists like to get into nooks and crannies in the rocks, etc. And also, if you have a human on Mars, they can sort of cognitively think. They can think and they make decisions and they can map. So what geologists on Earth, so when I'm in the field on Earth, if I'm in the Swiss Alps, etc., I'm sort of scrambling over the rocks. I see something over in the distance. I think, well, I can go over there or I can go over there. And I make decisions interactively, basically. And that's not something that a rover can easily do. And so I think eventually we will need humans on Mars. It will happen. I think it's just going to happen, basically. And we'll just be able to do amazing science with humans. So, for example, if Perseverance brings back samples and we discover evidence for life in them, we will absolutely send humans, because we won't be content with just those samples. And I'm sure people will argue about that evidence, basically. We have this on Earth. When people find evidence for the oldest life on Earth, it gets published in a fancy journal, and immediately people counter and say, no, that's not correct. And there's this to and fro going on. That will certainly happen. And I think what will happen, what we'll set forth is that people will go and want to go. And the other thing is that, we haven't actually been to many places on Mars with robots. It's very, very limited places. So it's hard asked to think that by sending a few rovers, we're just going to discover life just like that. It's not going to be that easy.
Yeah, of course. And do you know, is there a sample return mission in a design phase? And is there a launch date for one?
Yeah, so that's essentially Perseverance is the first stage. And I think John might talk about some aspects of this, but there's a plan, there's a memorandum being signed between the European Space Agency and NASA. And there's a whole array of planning going on at the moment and design stage at the moment. So this is really being taken very seriously. So actually the pressure is on us, on the Perseverance rover team, is that we have to select a really compelling cache of samples to bring back to Earth. This is going to be one of the most expensive space missions ever. So we have to collect really good rock samples. And what we can't do, so for example, when I'm exploring on Earth, say I'm in the French Alps, I'm at 3,000 meters elevation and I need to collect some samples to bring back to my lab. I will be walking around, and if I find a really good sample, I'll put it in my rucksack and I walk along and I find an even better sample. Well, I'll chuck the less better sample out of the rucksack and take the new one. Well, we can't do that with a rover.
Right.
The sample we collect. And so we have to have these really difficult decisions about sampling. But that's why we have such a huge team. We have a team with 400 scientists and almost 200 engineers. So we're working with very, very large teams to be able to make these very, very complex decisions.
Okay, great. Now, this is quite a fun question, I think. So how do the Mars rovers, how are they able to kind of rove around on Mars through difficult terrain without getting stuck?
Okay, so this is something we spend a lot of time on, or I don't, but the rover engineers, or the rover drivers are called rover planners because there's no joystick, basically. They're basically computer scientists and they're writing code, but they're also looking at the terrain maps. So what happens is that at the end of a drive, the rover will take navigation camera images, stereo images, to construct a 3D model of the landscape ahead of us. And what the rover planners can then do is they can design a route, working with scientists, working with geologists, looking at the terrain, and plan a routeway that avoids boulders, etc. We also have some capability of auto navigation. So if we've got benign terrain with no boulders, etc., the rover can actually drive and automatically navigate around features for short distances. But yes, we spend a lot of time looking at the terrain. We make maps that classify the terrain in terms of its difficulty and danger, and to be able to carefully navigate through that.
Brilliant. Okay. So this is an interesting one as well, actually. So why have no Mars rovers gone to the Martian poles yet? Because I think a lot of people are interested in the poles with the possibility of water ice and things like that. So why have none of the rovers gone to the poles?
Okay, so that's a really interesting question. And the reason is we're not allowed to. It's very simple. And there's a whole committee that deals with this. And basically, you don't want to go to Mars to search for life if you're going to bring life from Earth and discover life on Earth on from Earth on Mars. And the problem is obviously with landing, you will melt the ice, and any microbes on the rover lander could easily be transported and transmitted, basically. So that's really the reason.
Okay. Yeah. I mean, that's an interesting question in and of itself. You know, have we accidentally already sent microbes on these spacecraft out to different environments and things? So that's a very good reason. Okay. So this is just a more general question about Mars, but does Mars have tectonic plates?
That's a really interesting question. So it doesn't at present day. Some people think that it might have early on, or it might have had nascent plate tectonics. We can see some magnetic features that are similar to possibly plates, but the jury's still out on that. And certainly, actually, the beauty of Mars is it doesn't have plate tectonics, which means that these oldest rocks are preserved on the surface. So large parts of Mars, almost 70% of the Mars's surface is very, very old rocks of about 3.7 or older billion years. That's kind of around the time that life is thought to have started on Earth. And so, you know, given that we have so many of these rocks on Mars, it's a good place to search, basically. And on Earth, rocks of that age are either not preserved or they're heavily deformed and are very difficult to read, basically. So the rocks on Mars are pristine. So we see these rocks that are 3.5 billion years old in Gale crater, and they could be, you know, equivalent. They look like exactly like rocks on Earth that could be a few million years old, for example.
Okay, great. And I think we're just going to move on to the last question before we move on to the second talk. And one of the last questions was going to be, what's the typical depth of these core samples?
Okay, so our core samples are very shallow. They're only about 5 to 6 centimeters, because obviously the drill is on the arm, and so you can't drill very deeply. And so one of the issues with that people would raise is that we're only drilling 6 centimeters into the Martian surface, and that's within the radiation damage zone. So basically Mars is bombarded by radiation, galactic radiation, and that can destroy organic matter in the rock samples. So that is an issue, though we have obviously discovered evidence for organics in the samples. And John will actually tell us, hopefully, about the ExoMars rover, the Rosalind Franklin rover, which has something really dramatic that's going to do something very different to what the NASA rovers are doing.
Brilliant. Well, thank you very much, Sanjeev. And at this point, I'm going to hand over to Nigel to introduce to our second speaker.
Well, thank you very much indeed, Sanjeev, for that absolutely fascinating talk about what's being found in Gale crater. And please stick around for the rest of the show, because we're going to have some more questions at the end, I think, for both the speakers, and have a bit of a roundup too. But now we're moving on to our next speaker, who is John Chinner from Airbus Space and Defence. And he's working on the ExoMars mission coming up in a couple of years' time. And he's a self-confessed space geek. So please, John, tell us more about ExoMars and what's going to happen after that.
Hello, everyone. I've just been sitting here with my mouth wide open, listening to Sanjeev talking, and then suddenly realized I'm actually part of this and I ought to think about what I'm going to talk about. That's fantastic. I really, really enjoyed that. That's very, very cool. As I say, a self-confessed space nut, I think those kind of things are fantastic. So I'm just going to share my screen with you. So I'm going to talk you through the ExoMars rover and the ExoMars mission, and perhaps some of the things that we're going to do in the future as well, which are all very exciting. And Sanjeev has alluded to a few of them, so I'm quite excited to get on with this. But first, I'm going to start with a video. And that video is about 2 minutes long, and hopefully you've got your sound on nice and loud. Okay, so hopefully you can see the screen. I can't see myself anymore though, so I don't know. Oh, here we go. There we go. I'm back. Good. So it's quite an interesting video. You might have spotted the deliberate mistake in there. It said right at the end, launching in 2020. Well, you might be aware 2020 has been a bit of a rubbish year all around. So the mission has actually been rolled back, and it's now going to launch in 2022, that rover. Not because there's a 2-year delay on anything, but really because the planets need to go around again and come around the sun and come around again. So we can't launch to Mars whenever we want. We have to wait for the planets to line up, and that takes about 2 years. So we have to wait 2 years now for the mission to go, for the Mars to go around the sun, Earth to go around the sun, which is why the American rover was launched this summer, because 2020, middle of 2020 was the ideal time to send a rover. If I could skip forward. So there you go. So you saw some videos there of the prototype rovers on the Mars yard in Stevenage. So up in Stevenage, there is a huge room filled with sand and rocks, and it's a pseudo Mars. It's where you can practice your driving rovers on Mars. So this is Bruno here, and if you wanted to get an idea of the size of Bruno, you can see that up the top right, there's me with my hand up, pointing at the head of Bruno there. So about 2 meters tall. So the pan camera at the top of the head is about 2 meters from the surface. That gives it a really good vision all around. So up in the Mars yard, they can drive these prototypes around. So this is Bruno, and Bruno is what we call a high fidelity. It looks like the ExoMars rover. Now you saw another one in the video that was a bit thinner and a bit skinnier. That's Brian. Now Brian is made to be lighter, to be more like the rover when it's on the surface of Mars. Obviously Mars being smaller than Earth, gravity is less, therefore the rover will weigh less on Mars. So we have these two prototypes, one that weighs the same as it would on Mars. So it digs into the sand and sinks into the sand the same amount as the real rover would. So why explore Mars? I think Sanjeev highlighted a few things about why we go to Mars. I mean, really, it's all about organics. It's all about going and looking for life. Now, someone asked me, why do we care if there's life on Mars? You know, why are we worried about that? And for me, it's one of those fundamental questions that human beings want to find out is, are we alone? And it's not a question with a right or wrong answer. If we find signs of life on Mars, it doesn't mean there's little green men and there's things running around on Mars. But what it means is there's these two planets that have got life on them, and they're next to each other, and they've got a fairly ordinary sun or star, and there's life on both. Now that means that if we look out into the solar system and to other galaxies, our own galaxy, other stars, there are other planets out there that are in, you know, similar positions to Earth and Mars, and they would have a more high chance of having life on them if we can find life on Mars. But equally, if we don't find life on Mars, it could mean that Earth is the only place with life in the whole of the universe as we know it, which is another fundamentally quite exciting question. So either we are alone or we're not, and both ways that is quite exciting. Here you go. This is why we go and look at Mars and not at Venus, because Mars is in what's called the habitable zone away from the sun. So Earth, we know it's got life on it. So let's go look at Mars. It's in the habitable zone, which basically means that there's the opportunity to have water. Now, Sanjeev was talking about water on Mars. Now, there is water there now, we know that, and there has been lots of water there in the past. And we're going to go and have a look for those places where water has been flowing on the surface. We wouldn't find that on Jupiter or Venus. So this is a view of Mars, two pictures of Mars side by side taken from Hubble. And you can see there, Mars is not a very nice place, actually. The surface temperature can get up to 40 degrees in the daytime, and down to minus 140 in the night. So actually, it's not a very, very hot place. It's actually a very, very cold place. Very, very thin atmosphere. So there you go. There's a dust storm there. Look, you can see that on the picture on the right, it's the planet's surface is almost completely obliterated by dust. So we have to take those things into consideration when going and exploring Mars. Now, Mars, the surface of Mars is roughly about the same size as the landmass on Earth. So you imagine you're sending these robots to go and look for life. You've got the whole of the landmass on the Earth to try and pick where to go and look, and you've got to try and find life. So we've got to think very, very long and hard before we send that rover to Mars, where you're going to send it. It's very important because you could miss by a very short amount and not find what you're looking for just because you haven't sent your rover to the right place. This is a picture of Opportunity, and you can see the dust. The dust has an impact on your rover. You can see the solar panels there in Opportunity completely covered in dust. Now that does limit the lifetime of that rover. There are things you can do. You can shake the wheels, you can open and close the solar panels, you can do things to try and get rid of that dust, but that dust will ultimately kill your rover. It will cover the solar panels and won't be able to charge the battery during the day, and then it will slowly die. And there's lots of other mechanisms to kill your rover on Mars. But ExoMars, so ExoMars is a European Space Agency mission. It's in several parts. 2016 was the launch of the Trace Gas Orbiter. It's a satellite. It's still there in orbit around Mars right now. It released a little projectile onto the surface called Schiaparelli. It didn't land properly. It was supposed to land, but it didn't. But the thing is that vehicle was instrumented up. So as it was landing, or as it was trying to land, all that data was coming back. So although it wasn't a successful landing, we had all the data to look at and go, right, why wasn't it a success, and make the changes for next time. So 2022 follows the launch of the rover. Now the rover isn't going on a rocket on its own. It's going to be delivered to the surface on a surface platform that's coming from Russia. So here you can see the contributors to the ExoMars mission. You can see it's a really, global. It's a global project. You see, so there's the US and Russia involved, Canada and Israel, but then look at all these European countries. So we're very fortunate in the UK here to be the integrators for the rover. So what that means is that we take all the parts for the rover and we assemble them and we test them. So that is a place we've got in Stevenage. There's a bio clean room being made specifically for this rover in Stevenage, and all of the parts, so all of the locomotion systems, the body, the solar panels and the pan cam all come together and they're integrated in Stevenage. So they're put together and tested for the first time in Stevenage. So you can see there, it's a big international cooperation. So what are the mission objectives? Well, there's science and there's technical. So this, from the science point of view, we're looking for life. So there's the geological things, there's the interesting things you can look at in the Martian atmosphere as well, but also technical. So we're looking at entry, descent, and landing. How do you land things on the surface? How do you drive things around on the surface? How can you take samples on the surface? These are all mission objectives. So we don't take it for granted that we're going to land or going to be able to create samples. These are all objectives. So we want to go and meet those objectives, and those objectives ultimately lead to the science being able to be achieved. So I think you saw this plot, this map in Sanjeev's thing, and this gives you an idea. So this is Mars flattened out and rolled out. So this is the surface of Mars. So you can see the various landers that have happened right there. So just to the right, 3/4 as a blue disc, that's where Sanjeev was talking about Perseverance landing. So the ExoMars rover is going down on a place called Oxia Planum. Very interesting place, and it's about the bottom of the P where Pathfinder is, just to the north of Schiaparelli. So it's going somewhere different on Mars, but Oxia Planum is a very exciting place. It's a valley, it's had water flowing through it, so it's had sediments laid down, but also there's been signs of volcanic activity. So there's a possibility that volcanic activity, lava, has flown over that sediment and locked it away below the surface and protected it a little bit, made it a bit safer below the surface from all that radiation on the surface. And you can see on there, Schiaparelli, Pathfinder. If you ever watch the film The Martian, you can see that Mark Watley's in Schiaparelli crater when I think that's where he takes off from at the end of the, spoiler alert, sorry, and he goes to Pathfinder and takes pieces of it. So actually you can track the walk of Mark Watney on the surface of Mars in the film The Martian on a real map. And I've got one on the wall. So the ExoMars rover it's quite unique. It's going to be controlled remotely from the Rover Operation Control Center in Turin in Italy, but actually, like Sanjeev alluded to, not with a joystick controlling it real time. The ExoMars rover is going to be autonomous. It's going to be smart. It's going to be able to navigate itself around on the surface. So controllers in Turin will be sending it commands about where they want it to go and what they want it to do, but not necessarily commanding it how to navigate. So it's going to use its sensors. It's going to be clever. It's going to be autonomous. It's going to use its sensors to look around and map the surface around it. It's going to pick the best route to get from A to B. It's not going to do it very, very fast. 2 centimeters a second is about as fast as the ExoMars rover will go. That's 0.072 kilometers an hour or 0.04 miles per hour. It's not very fast. It's not going to move around the surface like a rocket ship or a Ferrari. It's going to be very, very slow, and it'll cover about 70 meters a day max. So over the mission duration, that means it's likely to travel around about 4 kilometers. That's 218 sols. Okay, so a sol being a Martian day, slightly longer than an Earth day, about 24.5 hours. So over those 218 sols, we'd expect that rover to have traveled around about 4 kilometers. So not very far in distance terms, but just think about this. This is a robot we've delivered to another planet, and we're driving it around, and it's looking at its surface, and it's navigating itself around, and it's doing that itself. So that 4 kilometers is astonishing. So here you go. This is a view of the rover itself. So there you go. So you can see what it looks like there. It doesn't look like Perseverance that you've just seen the videos with Sanjeev. It's slightly different. Perseverance isn't solar powered. It's got an RTG. It's got a radial thermal generator. But ExoMars, this rover is solar powered. You can see the solar panels on the top. And on the front, there's a black box, and that's the drill box. So that's a really important piece of this rover. This is something that no one's done before. But critically, I call it the ExoMars rover. We should be calling it Rosalind Franklin. It's been named Rosalind Franklin in honor of the British scientist Rosalind Franklin, who was co-discoverer of the structure of DNA. So it's fantastic to think that we're honoring this female British scientist in name with this ExoMars rover. And there is the real thing. So that's the actual ExoMars rover. It's been built. That's in a thermal test chamber in France. So that's the rover that's going to go to Mars in 2022. And you can see it there. You can see the solar panels. You can see its panoramic camera in that white box at the top. And you can see its wheels. Lots of the cables you can see hanging off it, they're all instruments that have been plugged into the thing while it's being tested. They won't go with it. But you can see there, that's what it looks like. And it's a fantastic bit of kit. It's very exciting. And that long rectangular black box you've got at the front, that's the drill box. So inside there are the drills. We'll get onto the drills in a minute. So the locomotion system, this is another key thing for the ExoMars rover. It's got a rocker bogie system, so the wheels can move around on the surface. It's got 18 motors, 3 per wheel, and it enables it to follow curves, crab sideways, and spin on the spot. It's very, very agile, and it will be able to do all those commands itself, working out the terrain and working out a route, and it will command itself. It has flexible wheels. There you go. The wheels are all metal. They're not rubber tires, because if we're going to look for life on Mars, life being we're looking for organics, we have rubber tires and we shed a piece of the rubber tire and we were to scoop that up, that would flag something organic. So we don't want to have rubber tires. So these metal wheels are made specifically to squash flat. They're like tank tracks a little bit. They squash flat on the bottom, gives it extra leverage, extra purchase on the sand and the rocks. You saw some of that in the video at the start. This is a little video. So the thing with the surface of Mars, as you saw in Sanjeev's photos, it's very sandy. It's like a beach. Rovers get stuck in that sand. We have heritage in the Mars rovers. So Spirit, one of the American rovers, got stuck in a sand trap. It could no longer move around on the surface, and that really limits your science capability. So learning from that, we've got some things on the ExoMars rover which will help it avoid getting stuck in sand traps. And I'm going to show you a little video. There's a little bit of audio. This is what's called non-drive motion. So this is moving without rolling your wheels like drive. So it's essentially walking. So using that gait, so it's essentially 2 triangles, keeping one triangle still and moving the next one forwards, and then keeping that triangle still and moving still and moving the next one forwards. It's hoped that the rover will not get stuck in the sand. It won't be turning its wheels to climb its way out and digging itself in further. It will be able to walk its way out. So that's a new thing that's been implemented on this ExoMars rover. And it means that hopefully it won't end up ending the mission early. So onto the drill. So Sanjeev mentioned that the surface of Mars isn't very nice. It's bathed in radiation. So we think any signs of organic are probably going to be quite deep below the surface. So mounted on the front of the ExoMars rover is a drill. Inside this black box here is a drill. Now that drill is capable of going down 2 meters into the subsurface of Mars. So it's going to go down. It's got a drill piece and 3 extra extension rods that go down. It can go down to 2 meters. Now that's no one's drilled 2 meters into the surface before. So it's quite exciting to think it's going to take a sample from 2 meters down, bring that sample up, deliver it to a lab on board the rover and analyze that sample on Mars, and then send the results back. That's quite exciting. No one's ever been 2 meters below the surface. That's something that ExoMars is going to do that no one's done before. And here's a little video of the flight ExoMars rover. It hasn't got its wheels or its solar panels or its neck or its head attached there, but that's the drill box being tested, being rotated around. So that drill box rotates around. I've got a little model here. I can show you how this works. So there's the front of the ExoMars rover. The drill box turns, goes down. The drill bits come out of here into the surface, take a sample, come back up into the box. The box will rotate around and it will deliver that sample through the window on the front of the rover, through this little window here. That's then taken on board the rover and processed inside. This is a nice little image. This is Rosalind Franklin's niece, also Rosalind Franklin, meeting the ExoMars rover that has the name of her auntie. Nothing specific about that photo. I just think it's a really cool photo. And I can see the look in her eyes is pondering this weird, gangly looking robot carrying her auntie's name. So this is the bio clean room in Stevenage. And you can see there on the left is the rover. In the middle are some of the engineers who are integrating it. And on the right is someone taking a picture. So that's quite a cool picture, being able to have a picture saying, I built this ExoMars rover. Now, I was quite lucky to be able to go along and see that. And that's me looking very, very happy for myself, looking at the flight rover through the window into the bio clean room. Now, it's got to be a bio clean room. It's not a normal clean room like you would build a satellite in. It's a bio clean room because we do not want to export any signs of life with us on that rover. You can see the way that those engineers are dressed. They cannot shed any skin or get any hair or anything like that on that rover, because if we find that on the surface of Mars, it will be a sign of life and we would analyze it and it will be quite confusing. We do not want to contaminate Mars. Someone said to me, we don't want to go to Mars and find signs of life came from Stevenage. That would be a bit of a shame. So a special bio clean room has been made to make sure this thing is super, super clean. Actually, there is a limit. It doesn't have to be perfectly clean. It has to have a certain amount of spores on it, and the number isn't 0, which is a surprise. You think it'd have to be perfectly clean, but actually it's very, very low, very, very low, very, very difficult to do and difficult to achieve. And now we've got to store that rover for another 2 years and make sure we keep it clean. So I've whizzed through this totally quickly, so I'm sorry if I've going so quickly, but I want to talk about the future a little bit. At Airbus Defence and Space, we've got this heritage now. We've built the ExoMars rover. We've got a centre of competence here in Stevenage, and we know how to build rovers. And we're capitalising on that by this Fetch rover. Now, Sanjeev alluded a little bit to what the Fetch rover is going to do. It's a fantastically bonkers mission. When you think about it, it's ridiculous. You can see on this image, there's 3 rockets, there's a number of satellites and a few rovers. All of this has got to happen in sequence and work for actually to be able to bring these samples back home again. But I'll run you through the timeline here. So on the bottom left, you've got the Mars 2020 mission. That's what's already launched, and it's delivering the Perseverance rover to the surface. So you've got Earth at the bottom and Mars at the top. So the Perseverance rover is on Mars on the left-hand side. It's going to go around, and it's going to catch all those samples that Sanjeev showed you, and it's going to leave them on the surface. Now, the sample retrieval lander, a NASA rocket, is going to launch. I've got the dates here actually for this. Let's have a look. So 2026 is around about the time when that rover will launch on that NASA rocket in the middle there, and it will go and it will deliver the Fetch rover on a surface platform, and that Fetch rover will go and find those cached samples, and the Fetch rover is going to be able to travel 200 meters per day. So the ExoMars rover we're talking about 70 meters a day tops. This is going to be able to travel 200 meters a day, go and find those samples, bring those samples back to the surface platform, which will then perform the first takeoff, or the first ascent from Mars with those samples on board. And then in orbit around Mars, we'll be waiting an Earth return orbiter, which will be waiting around the surface, the atmosphere of Mars, collect that sample, and then bring that sample back to Earth and then drop it down. And it's so bonkers, but there you go. You can hear from Sanjeev how important it is for these scientists to get their hands on those samples. There's only so much you can do with a rover on the surface. People say to me, why do we send robots? And you give them a really great answer. And they go, well, why would we send humans? And you give them another answer, because humans can add the context to this as well. So you can tell your rover to go and have a look at a really interesting rock, and it will look at that interesting rock all day. But if you sent that human to go look at that interesting rock, that human might go, that's a lovely rock, but the one next to it is even better. And you might miss that with your robot. You might not miss that with a human being. So I still think, I'm with Sanjeev on this. I think the merits of sending humans to Mars, we might be able to do all the science we can using remote observational robots. But actually, I think as humans, we will desire to send humans to Mars at some point in the future. So there you go. That's the sample return mission. It's bonkers, but we like bonkers.
Thank you very much, John. I think we're all having our minds a bit blown by what's going to be happening in the future with Rosalind Franklin, and then with the Mars sample return mission. We've had some questions coming in about a lot of people are concerned about the solar panels and the dust building up on them, if there's any way of shaking the dust off, or in fact, the more fundamental question of why did you choose solar panels rather than a nuclear power source such as Perseverance has?
It's a really good question. So yes, there are mechanisms. So shaking the wheels, just juddering the wheels can shift that dust off your solar panels. Now, it will be a long thought out process right at the start of the mission to decide what we're going to do with this thing. What we're going to do? We're going to send a rover. How's it going to be powered? And all the things to do with the instruments and the surface mobility will have to come from that power source. So somewhere back in the day, someone would have decided that solar is the way to go. So it's only actually Perseverance and Curiosity that are RTG nuclear powered. Spirit and Opportunity, so as you know, all the ones before that have all been solar powered. It actually is quite a neat little way of powering your rover. If you're not powering around the surface, you're just going to go slow and steady. That's great. So the rover is scaled to be able to provide 218 Martian days of power. So that means it's got more solar array than it would probably need, because it will take into account the degradation over time of the dust. So it needs to work for 218 days. All the things you put into that rover to make it work for 218 days, like having oversized solar panels, having 6 wheels, having the sand trap escape ability, that means it will probably go longer, which is why Opportunity was still going a couple of years ago. It was 10 years into its mission. It was only guaranteed for a couple of months, and it went for 10 years. But all the things you put into your rover to make it work generally mean they go for a bit longer.
We've also had some questions about the drill. You've told us about the immense depth of 2 meters, I think, it's going to go into the ground. Given the low gravity, how do you actually get it going down that deep? Do you have to grapple the ground to actually hold on to it? So the rover just doesn't lift up?
No, so the drill has been designed to go through lots of different surfaces. We don't know exactly. No one's been to that depth. We can look at the geology of the surface and say, well, we know roughly what's underneath. On the back of the rover, though, actually, here on the back, these are ground penetrating radar. So they will shoot down through the surface and actually have a look and see what's below there to make sure you're not going to drill through something that potentially could damage your drill. So the drill isn't there to be used ad hoc. It has a certain amount of life cycles it can be used for, a certain amount of samples, around about 17 cycles it can do. So you have to think very, very long and hard about where you're going to go and take your sample. But critically, that we know the surface of Mars is bathed in radiation. So if we're looking for some kind of organic, it's going to be destroyed by that radiation. So we really do need to get nice and deep. We do need to get 2 meters down, and it'll be really interesting to see what's under there, what's down there. And it's fantastic. There's a European Space Agency mission is going to go and drill 2 meters down.
It's amazing. What I'd like to do now is to invite Emily and Sanjeev back into the discussion and open it up just for the last couple of minutes of questions.
Yeah, thank you very much again, John. It was an excellent talk about a different sort of rover that is going to head to Mars. And actually, there have been a few questions come in asking about the main differences in what the Perseverance rover and the ExoMars Rosalind Franklin rover hope to find. So I thought maybe John and Sanjeev, you could elaborate a little bit more on the differences between the 2 missions.
So Perseverance is really geared to Mars sample return. So it's actually very different to Curiosity, for example. Curiosity is very much an exploration mission. Perseverance is going to get a very, very tight timeline. It's going to go to Jezero crater. It's going to very, very quickly, and we've chosen Jezero crater because the geology is relatively simple. We think it won't be when we get land there, but it's relatively simple. We will land, we will analyze the geology, collect samples very quickly, and then drive out of the crater is the plan to go and explore these really, really old rocks that form the plains around Jezero crater. So what we're trying to do is to get a huge range of rock types, because to be honest, we don't really know where we're going to find life. You know, we have ideas, but we can't be certain. So we want to explore, and you know, there may not be life on Mars. So we want to learn other things, and we want to learn about the geology of Mars and the evolution of Mars as a rocky planet. And so that's why we want to get a diversity of rock types. John?
Well, yeah, I mean, I guess the differences are there. Yeah, there's hardware differences, but I guess the overall mission is to understand more about this planet, our neighbor in our solar system. You know, is Mars, is it like Earth was in the past? From geology terms, you know, we're gonna learn more about Earth from looking at Mars. And you know, again, it's these two planets in the Goldilocks zone around this ordinary star which we call the sun, and we can learn a lot from looking at these two planets and then projecting that out into other exoplanets around other stars, and understand more about them from what we can learn from Earth and Mars.
Brilliant. Thank you for that. Now, I think we're running out of time, unfortunately. We still have lots of really amazing questions that we haven't had a chance to get to. But before we kind of move on, I just would like some final words from both Sanjeev and John. What is the most exciting thing that you both are looking forward to with the next kind of new set of rovers? So what are you really hoping to find out about Mars?
Shall I go first on that one?
Yeah. Well,
the thing is, for me, you've asked the question of myself. This is me talking as a human being here. I love these missions, and I love these sending these robots out into space. But actually, I really am passionate about using them to inspire young people into science and engineering jobs. And these are the things that we need to remember, that we go look for the science on Mars, but let's build in some outreach. Let's get young people, let's get excited about these things we're doing here in the UK, things we're doing in Europe, and sharing the message of we can do great things when we work together in teams, international teams, and bring through the next generation, and to think about they could be the humans on Mars, not us, not me. It's these young people in schools right now. They're going to be the humans on Mars.
That's great, John. Yeah, for me, it's just this amazing sense of discovery and exploration. Humans have always explored, and we're not limiting ourselves to Earth, and we're sending our robots and eventually humans out. And for me, it's just amazing to get these fantastic images. You know, we plan a mosaic with our cameras, and then a few days later we'll get this vista of the Martian landscape, and it's always slightly different, etc. And I have to say that, you know, whilst we've taken these for science, the first part of me looks at them artistically. You know, you have this sense of the beauty of this Martian landscape, and it is, you know, dry and arid and kind of desolate, but there's still a strange beauty to it. And for Mars, it's Earth-like in a weird sense. So, you know, I've spent much of my career working in desert areas in the Western US and in Egypt, and there's a sort of familiarity to it, and yet, you know, it's somewhere else, and that is just extraordinary.
Brilliant. So thank you again, John and Sanjeev, for excellent talks. And at this point, if you would like to stick around to answer some of the questions, so to type some answers to people in the Q&A, you're welcome to do that. But otherwise, I'm going to hand over to Nigel for the second half of our evening.
Thank you very much, Emily, for co-hosting the first part, and to both our speakers again for those excellent presentations. And now, as you say, we're going to go outside to see Mars for real, and anything else there is up there in the sky. And joining me as a co-host for this session is Les Brand, who is a part-time astronomer at the Royal Observatory at Greenwich, and he's joining us from his own observatory in Essex in the east of England. Hello, Les. Are you there?
Hey, hi, Nigel. Hi, everyone.
Hi there. Now, how's the sky looking for you?
Well, it was touch and go about an hour ago. It's not looking too bad at the moment. I'll perhaps click on in a little while. We did have some clear skies earlier, and then all of a sudden some clouds came over, and I thought, oh no, and I was getting messages from David and Chris and the other guys, and but you can see I'm here, I'm all wrapped up nice and warm, and I'm a bit envious of you guys on the previous session, all sort of in your nice warm homes. Here it's about 10 to 12 degrees and quite humid. It's about 72% at the moment, so out there.
But you can see Mars. You see Mars through gaps in the cloud. Yeah.
Yeah. I mean, let me just give you a flavour. I must say that I'm also, as you mentioned, based out in Essex, on the edges of London, actually, London Borough of Havering, and I'm representing also tonight the Havering Astronomical Society. So hopefully, anybody that lives in the area and would like to find out more, get in touch. But let's have a quick look. What have I got here?
Yes.
Okay. Now, yeah, what we're seeing here is unfortunately, is a very poor image. I'm just going to go over to my screen here and ignore that strange dot there. That is one of these wonderful dust bunnies that appears from time to time on or around our camera sensors.
When you say dust there, Les, obviously that's not dust on Mars, that's dust in your telescope.
Indeed. And I mean, if you didn't know any better, you'd think there was a dust storm completely covering Mars right now. And in fact, there is the beginnings of one. I know there were some wonderful images earlier this week from our friend Agapios in Cyprus that was actually showing how that dust storm is sort of creeping round. I think it's actually coming around this sort of lower quarter here. Let me just do a quick adjustment here, see if I can bring it up a little bit. As I say, it's jumping around a lot. The seeing's not great. I'm actually imaging this through a fairly modest telescope. It's a 7-inch Matsukov telescope. Now that's a type of telescope that it's a reflector telescope, so it's actually got a couple of mirrors in it rather than the traditional sort of telescope where you look down the sort of narrow end, and it's got a special camera at one end that's actually capturing the light that's coming through and bouncing off those mirrors. But the aperture where the light comes in is only 7 inches, which isn't bad. It does the job. 180 millimeters in today's money, and but it's got quite a long focal length. It's 2,700 millimeters, and I've actually got a Barlow on this as well, which is probably not helping the image that we're seeing. But what you should be able to see, let me just see if I can adjust the position. Oh, wrong way. There we go. What you may just, that was my guider just adjusting it back. It doesn't like to be moved. You could probably just about make out this sort of lighter region at the top. This is the
yes, I can definitely see the top half is lighter than the dark half and the bottom half.
Exactly. I mean, it's just about there, and I think we call that the sort of I think we call it the Mars dichotomy. Actually, very sort of strange sort of name, but it really represents the difference between the northern hemisphere, which is the sort of flat or the lowland plains, which may once have been full of liquid water oceans. There's a lot of evidence of that, but it's really the lava plains that have smoothed out. And then the darker regions, and apologies for this dust bunny, it's right in the way there. It would be good if it was something other than dust, though, wouldn't it?
A flying saucer would be even more interesting, but I don't think so.
Indeed, yeah. But in the southern region, it's more upland, more sort of heavily cratered. Of course, Mars doesn't have a great atmosphere to protect it from bombardment of space rocks like asteroid impacts and so on. So there's some quite large regions there, sort of fairly heavily cratered, of course. But what we can see, I've got let me just see if I can show my image of Stellarium.
So this is in the computer software, is that right?
This is in the computer software. Yeah, this is something that certainly amateur astronomers make good use of. And in fact, for anybody, this is free to download. It's a wonderful application, but it effectively helps us to see where is Mars in the night sky.
So you're zooming out here now, we can see the stars around it. Yeah.
Exactly, and I've left the constellations on so that you can get a feel for perhaps some of the names of the constellations. Now, there's Mars, and actually all of the other planets follow this sort of imaginary red line. This isn't a laser light that somebody's shining in the sky. We call it the ecliptic, but it's actually the path, if you like, or the plane. It represents the plane, the flat disk that all of the planets and the moon and other objects in the sky sort of form across the solar system. And the planets will travel, broadly speaking, across that line. And if you look down to the right-hand side, you'll see these three objects here, which are actually labeled for us. The moon, which is a thin crescent at the moment, and then we've got Saturn and Jupiter. And I think a little bit later on I'll be able to show you, and I think a couple of either Chris, Dan, or Dave may also have some images of this wonderful conjunction, as we call it, of the moon, Saturn and Jupiter, all fairly close together. So there we have that. And just before I will just zoom in again, one thing that we can't see through my scope, partially because of the aperture, but also the settings and the glare from Mars will just blow it out, is the two moons of Mars.
Mm-hmm.
We can see them here, Phobos and Deimos. And these moons are fairly small. They're sort of 15 to 20 kilometers across, and they actually orbit around Mars very rapidly. And I can do a quick sort of simulation here. We're about an hour let's just move it on. Oh dear, where do we go? There we go. Let me lock Mars in, and then we can see, just by advancing an hour, how quickly those moons are actually orbiting.
That's incredible, because you see the planet itself is not turning all that much in that time, but the moons are just zipping around.
Yeah, correct. I mean, Mars itself spins on its axis just slightly longer than the Earth takes. So it's 24 hours and 37 minutes. So from day to day, and if for those of you that have watched these sessions over the past few days and have got clearer views, you may actually have seen these same features appear. They'll be slightly shifted. So we've got this sort of wonderful view of seeing these small moons of Mars and orbiting. And if I just change the view, now this may be interesting, given that the last speakers were talking about being on Mars.
So this is the view from the surface of Mars.
And this is the view from the surface of Mars. Yeah, and indeed, this is the small lander Spirit.
Right.
There it is. Say hello. It's
I believe it's defunct now, unfortunately.
It's defunct now, but with the power of selfie technology and some wonderful landscape artistry, we can actually take a look as if we were in the crater that Spirit landed in, and looking out. I've actually switched Mars atmosphere off here because it would just sort of cover the view a little bit. But actually what we're doing here is looking back from Mars towards the Earth, Venus, Mercury, and the Sun. What a magnificent! And now, obviously, this is simulated in the application, but we can almost pretend that we're there and just sort of spin round a little bit. That, by the way, signifies my telescope, where my telescope would be pointing if it was on Earth. So just ignore that. But what an amazing view on this wonderful app. It just helps to bring alive some of the things that everybody's been talking about in this wonderful week.
Absolutely, and I guess if you're looking at those in the sky, we've got Venus as the morning star at the moment, and the Earth and the Moon would appear actually as a double star in the sky.
Yep, yeah, indeed. And I think, if I'm correct, in about sometime in December, I'm not sure of the exact date, but Jupiter and Saturn will be very, very close together.
That will be the December the 21st, over the grand conjunction. They're going to be closer together, as is Jupiter and Saturn, which we're seeing now with the Moon. They get closer and closer together, and on that date they'll be closer than they've been in almost 400 years. It was the year 1623 when they were actually last this close together. So we're all praying for clear skies on December the 21st.
Indeed, that'll be magnificent. That'll be magnificent. I've got a few other bits that I can sort of come back to. I was just
going to suggest maybe Les, if we could see if somebody else has got a view of Mars, and we'll come back and we talk a bit more about the Havering Society, perhaps, and what else you have to show us a bit later on. Yeah,
great. Thanks, Nigel.
So who do we have next? Who do you think has got clear skies? Have you been monitored?
Okay,
yes.
Can everybody see that?
Yes, it's come up there. Yeah. Okay,
so. I'm actually using a telescope very similar to Les's. Mine is an 8-inch Maksutov rather than a 7. And I'm also using a Barlow, so I'm working with an 8-meter focal length. Although the image is shimmering about a bit, it's actually not as bad as I thought it would be.
We have better than Les's. You're a bit luckier there with the Earth's atmosphere affecting it.
I think so. Well, we have a very strong jet stream right overhead at the moment.
So could you explain what the jet stream is?
Well, it's basically, it's a very high-speed river of air in the upper atmosphere, which airline pilots sometimes use to go faster than normal. But it blows at something like 150, 170, 200 miles an hour when it's really strong. And unfortunately, it's also very turbulent because there's bits of air of different temperatures which are mixing together and creating this shimmering that you see in the image there. And there are now websites that forecast the jet stream, and you can look and see when it's not going to be strong in your location, and those are usually the nights when it's better to try and do imaging because the air will not be so turbulent. I see I'm sort of coming in and out of view there. If I brighten my screen a bit, that might help. I can see me a little bit anyway.
Okay, yeah, we can see you better now.
Yes.
But look at the image of Mars. Do you have any images you've taken where you've managed to get rid of the turbulence by taking fast frames and stacking them up?
Well, this is running at 30 frames a second at the moment, my video camera. So yes, it's possible to capture a video like this and then process it. I'm not sure I'm set up to do that this evening. I wasn't actually expecting it to be clear, but I can give that a try if you like.
We got too lucky.
Yeah, I know. Well, if I just capture a minute's worth of video, that should be about 1800 frames. I can I'm not sure I want to do the stacking and everything live. I can do that, and then you can come back to me later on perhaps, and I'll show you what I've got.
That could be a good thing to do, because what we can do is see how that image is shifting around with the atmosphere, and then perhaps we can see later just how you can use software to sharpen it up and see the details.
Yeah, it's actually quite remarkable. I mean, it's shaking and sort of vibrating a bit, but actually it's not too bad. If you look to the bottom, almost at the bottom of the image, you can see a very slightly light patch, maybe at about the 6:30 position, which is the South Polar Cap I'm afraid I'm not one of these traditionalists who insists on having the south pole of Mars pointing upwards. I like to see things the way they are in the sky.
Chris, can you explain just for a second for some of our viewers who are not used to looking through an astronomical telescope why you should turn Mars upside down so the south is at the top?
Well, this all goes back to the early history of the telescope, when a telescope was just two lenses, a big lens at the front to collect the light and then a smaller one to look at the image. And in those days, 300 or 400 years ago, they didn't have anti-reflection coatings on the optics. So every surface lost you some light. And in order to turn the image upside down, or sorry, the right way up, you would need to have another lens between the image and the eyepiece, which would mean two more surfaces. So you would lose 30% more light.
Mm-hmm.
And it was just considered that it was preferable, since you can just look at a star or a planet in the sky, you can't see which way up it is. It was considered better to just use two lenses and accept the fact that the image was upside down, rather than add another lens with more light loss to get it the right way up.
That's because an astronomical telescope naturally just turns the image upside down unless you compensate for it. Yeah.
I mean, for a naval telescope, such as a sailor would use to look at distant things on the horizon, you do need the image the right way up.
Mm-hmm.
And those telescopes, the ones that literally the telescoping ones with lots of tubes that pull out from a short thing to a long thing, those would have in them what's called an inverting lens to turn the image the right way up, so that you could see so the ships would appear to be sitting on the horizon rather than hanging from it upside down, which would be strange.
If you're looking at the flag signals, maybe you might get the wrong message.
You might well get the wrong message.
What Nelson would have done if people had misread his message. Just while we're looking at this Mars, actually, Chris, one final thing. This is obviously being recorded by your camera at 30 frames per second. Now, if you or I or one of our viewers had our eye, I mean, ideally, we would all been at, not all of us at your observatory, we'd all have been out visiting an observatory and people looking through the telescope for the first time. Is this how it would actually look to your eye looking through a telescope, or if you were showing it to a visitor, this is how it would look?
More or less, yes. The camera is perhaps a bit better than the eye at picking out the slight shadings and the details. And obviously there is a degree of persistence of vision in the human eye, and so you might not see all the shaking and the turbulence that you're getting on the camera image, because that's capturing an image very quickly and then displaying it and then capturing the next one. The human eye has persistence of vision, which is why cinema and television look smooth, and so you might not see all of the shimmering and shaking that you're getting at the moment.
Okay, we can see. Well, maybe we could come back and take a look at your process image a bit later.
Sure. Well, I'll get on with that, and then I'll put a message in the chat when I'm ready to show that.
Great. Les, do we have somebody else who we could go to now, do you think, and see what they're viewing?
I think we should have. Hang on, I'm starting my video.
Yep.
Yeah. There we go. We should have Dan, I hope, from Kilda, or Dave Strange. How's it look? Oh, there's Dan. How's it looking for you, Dan?
Yeah, good. Can you hear us all right?
Perfect.
Yeah, we had some audio issues, but we've managed to iron them out.
Excellent. How's the skies?
It's coming and going at the moment. So it was nice and clear, but it seems to have clouded over a little bit now. I can see just on the screen next to us that Mars is coming in and out of view just through the cloud there. But it's been hit and miss all night. It was beautifully clear all day, and then it's got to this time, and the cloud seems to have set in.
Indeed, there's times like that when you need to do some solar observations, isn't it?
Sure.
Do you want to tell us a little bit about Kilda and what you guys are doing up there? And I'm sure everybody would love to know because it's a fantastic setup up there.
Yeah, absolutely. Yeah. So if you haven't been to the Kilda Observatory before or heard about the Kilda Observatory before, we're a public observatory in Northumberland, in the largest dark sky park in Europe, or the largest gold tier dark sky park in Europe. And we're 2 miles up a dirt track in the middle of a forest just outside of Kielder, which is the most remote village in England. So we're in the middle of absolutely nowhere, which is great for what we do, of course. And most of what we do is public outreach. In fact, 99% of what we do is public outreach. We run events 7 nights a week generally and welcome the public here to use our big telescopes and hopefully inspire them and teach them a bit more about astronomy. And that's kind of our day jobs, if you like. That's what we do 7 days a week. And we've got behind me, we've got George just over here, socially distanced behind me. And over the other side, we've got the other Dan. Hello. Just there as well. All full-time members of staff here. We've got 10 full-time science presenters. And we've got also 10 telescopes as well. We're inside our 16-inch telescope room. We've got another room which is slightly bigger than this, which has a 16-inch Ritchie-Cressy style telescope just further down the road there. And then we've got some telescopes that we use outside and some imaging telescopes which are hidden in a room over the other side in a separate building to where we are right now. So that's really us, I guess, in a nutshell. We do have a video of our setup if you'd like to see us setting up to view Mars.
Yeah, excellent. That would be brilliant. And perhaps if you've got any, how shall we say, Blue Peter moments where here's something I've prepared earlier would be fantastic. Yeah,
we certainly do. Yeah, you should be able to see. I'm not sure if you can see that we're also signed in as a panelist under a different account. Yeah, that's us there. Great.
Yes, I think I have spotlighted it for you.
Excellent, thank you. And you should hopefully still be able to hear us. That's great. So I'm going to go ahead and play this video, and I hope that you can hear the video.
My name is Dan, and I'm one of the astronomers that works at Kielder Observatory. We have brought you inside of our 16-inch observatory. It's named that because we've got a 16-inch telescope inside of it, and we're hoping to get some good views of Mars tonight. So what we've done is we've installed a camera into the back of the telescope. This is a planetary camera, and it takes a high frame rate video so we can live stream Mars to you all a little bit later on. We're just hoping for the clouds to disappear, and when they do, well, the forecast is all right, so hopefully we'll get to see it later on tonight. So the next step is we'll be spinning the telescope round. We're going to do that using a computer over the other side of the room, and we're going to turn it to Mars, and we're going to get it in position ready for later on.
that was us setting up a little earlier on tonight. And this is our live look of Mars at the moment. We're just going to put it back in the middle.
Oh, wow. Excellent.
But there we go. We've got some Mars. We've got a clear patch back. So I'm going to grab George. So George is going to talk to you now about Mars.
Yeah. Hey, George.
Hello. Hi, yeah. So I was just going to say a little bit about Mars. Unfortunately, we missed a few minutes at the start, so I'm not sure how much other people have already talked about their view of Mars. I don't know if we could turn the gain down on this, could we? Just a little bit. But yes, as Dan mentioned before, we've got our 16-inch telescope just behind us with a planetary camera on it, looking at Mars at the moment. I'm just going to try and make it a little bit easier to view. 1 second. Oh, and then up a bit. Yeah, there we go. That's probably the best we can get it. But you can certainly see some of the darker features there at the bottom of Mars, and also the white polar ice cap as well, which I believe is the south polar ice cap, as mentioned before, and those brighter patches, which are dustier regions on Mars's surface, really. So these darker regions that you can see towards the southern part of the Mars, there is those are actually where sand is scraped away. The dust has been sort of taken away from the surface due to like the winds on Mars, and so it leaves behind the actual rocky surface or basaltic rock on Mars, which is a bit darker. So that's the reason for the difference there in colors. But I hope you can all see that okay.
Yeah, it's coming through brilliantly.
Yeah,
good definition there.
Yeah, the seeing conditions, they're probably the best they've been all night right now, actually. It's a little bit wobbly, but we were all learning a little bit, actually, talking when you were talking about the jet stream above in the atmosphere, and that's obviously the reason for the turbulence there. I know we've got a very cold weather front coming in as well, which is probably making a bit of a difference, but not bad, I don't think.
Oh,
yeah,
excellent.
It's been all like that.
Yeah.
And would that slightly lighter area, say at round about 5 o'clock, would that be that hint of the dust storm, do you think?
It could be. We thought it was the polar ice cap at about 5 o'clock. Although
no, that is. I think that's the dust storm. Yeah, because I've seen some drawings of it the last few days, and it looks like, yeah, that's the first time we've picked it up tonight.
Right.
That must be it. It looks like it's in the right place, doesn't it?
Yeah, marvelous.
Yeah, I think it is. Yeah, I think it is.
Bit difficult to tell, but yeah, possibly. Yeah, the dust storms. The reason why you get dust storms, especially during the summer months for the South Pole at the moment, with it pointing more towards the sun, is that it's the carbon dioxide ice which covers the polar ice cap there is turned into gas as it heats up under the sort of solar radiation, which then causes this turbulence in Mars's atmosphere, kicking up all of these dust storms. And that's why you tend to get them during the summer months on whichever pole is facing the sun, if you see what I mean.
It's absolutely magnificent. The more I look at it, the clearer it seems to get. It's that sort of, I think Chris mentioned it earlier, that persistence of vision, isn't it? You know.
Definitely. Yeah, you can also just about pick out the sort of termination. I think Mars is 94% illuminated at the moment. So it was at opposition 2 or 3 weeks ago now. So yeah, you can just about pick out that termination there on Mars as well.
Yeah. I'm just thinking if I don't know if you want to come back soon, I could get a Barlow on that so we can get it to 8 meter focal length and see if it's any good, because it's the best it's been all night.
Yeah,
we could maybe increase it, and we'll get a view
absolutely.
maybe in 5 minutes or so if you want me to do that.
Brilliant. Yeah, I'll really look forward to that, because I think that it'll make everything hopefully stand out and be more prominent as well. Yeah. Excellent. So did you want to do that? Have you got anything else that you want to talk about at the moment?
I'll pass you back over to Dan, who's going to show you a couple more things, I think.
Okay, excellent.
I'm not going to show you anything. No, I guess we've got some pre-recorded stuff which we took a couple of weeks ago. But one of the things that I did really want to show you, because we're looking at Mars through a telescope, why not let's have a look at Mars through a microscope? So we've got some Mars rock here at the observatory. And on the screen right now, on our sharing screen, you should be able to see, hopefully, an image of Mars just there. So this is a piece of our Martian rock. It's a basaltic piece of Martian rock. It's incredible. It's only very, very small. But the thing I love about this, and the reason why we love having this piece of rock, is just that when guests get to come and visit us here, they can leave having held a piece of another world, and that in itself, I think, is an incredible thing to consider. And more recently, what we did as well was we've mounted a piece of Mars rock into our floor, so you can stand on Mars at the Kielder Observatory now, as well as part of the experience.
Yeah, I think it's a wonderful thing. The idea you can get pieces of Mars rocks which have landed on the Earth as meteorites. I think it's a great, with Christmas coming up, is a great Christmas present to give to your loved one. Not just saying, I'm going to give you the moon, I'm going to give you a bit of Mars.
Absolutely, yeah. They're incredible things to collect our meteorites. They blow my mind every time we talk about them, every time we look at them. It's just their age, the places that they've come from, everything about them is just so incredible. I'm just...
And if you get one that's come from the inside of an asteroid, which is melted and then solidified again, you're actually handing a piece of pure metal, which has come from the core of a planet. When we think about, we can't get to the core of the Earth, which is much nearer, but you can actually handle the core of an asteroid, which was broken up in the distant past, and the bits have fallen down onto our planet.
I think Dan's just about getting everything into focus behind us with our Barlow view of Mars. So I'm just going to try and bring that back for you as well.
Actually, bring the exposure up.
So do you guys do sort of robotic observations up there, or is it all sort of hands-on in the observatory?
No, so we're both of our telescopes are on, or both of our 16-inch telescopes are on Paramount ME2 mounts, and that's what we use primarily, really. And we do use 2 Dobsonian telescopes as well, just for public observing out on the front deck. And then we have a further 2 more Paramount robotic telescopes in the other building as well, what's called the Gillian Dickinson Astro Imaging Academy. Here we go. We've got some more Mars action for you here. I'm going to pass you back over to George. He's going to talk to you about Mars again.
Is it okay?
I think I've got it about right there.
Yeah. I don't know if they can see.
I'm not sure if it's any better or not, but
no. So you've put in the Barlow.
Yeah. So I put it 2 times Barlow in.
Right. So yeah, I mean, there's not much else to say really from in terms of what we can see, but we've put in the 2 times Barlow lens, so we've now increased the focal length to 8 meters, I think. Is that right?
Yeah,
8 meters. Yeah. So I'm not sure if that's made it any clearer. Is everyone seeing that okay?
Yeah, we're seeing absolutely fine. To me, I can see the detail, but it's still very blurry and very wobbling about, but the detail does seem clearer at this magnification.
Yeah, I think the wobbling about might be a little bit because we're walking about, so we'll stay still. Because although our telescope's on this big concrete block, which is detached from all of the decking around here, it still does sense some of the vibrations from us walking about, but not too bad. So yeah, that's definitely a little bit off center where I'm talking about the light patch on the bottom half of Mars again, definitely the dust storm, because I'm pretty sure that the ice cap is further around, at sort of 7:30.
Yes.
Definitely, yeah. So that's the dust storm there, brewing at about 6 o'clock, like you said.
Looks nice.
But yeah, the different regions on Mars's surface generally are called sort of terra and planums, and so there's these big expanses of Mars's surface which are a little less marked by craters and sort of channels, ancient river channels, etc. And those tend to be slightly lighter in color, which is what you're seeing in the sort of northern hemisphere there as you look at Mars, compared to the darker regions on the southern sort of hemisphere of Mars there.
Oh, got a question there. So how do we know they're actually a piece of Mars.
How do we know? So talking about the meteorites, yeah, we've got a question. How do they know they actually have a piece of Mars? So there's actually 4 or 5 different bodies in our solar system which we know exactly the chemical composition of, and Mars is one of those bodies, one of those planets. The others being the Moon, Mercury, Earth, of course, and missing one, Mars. Yeah, that's the 5. I'm pretty sure. And it's just down to chemical analysis. So once you've found what you think might be a meteorite, you can send it off for chemical analysis. They break apart, scientists break apart this piece of rock. They look for different abundances of certain chemicals, certain minerals as well. And if they can match that up to what exactly they can see the surface of Mars to be made of, then you've got a match. And you know that it's come from Mars and it can't have come from anywhere else. Yeah, so that answers that question.
Do you have any other observers, do you know, Les, who are seeing anything at this present? Sorry to interrupt you.
No problem. Go ahead.
I just wonder how everyone else is doing in the country.
I was just checking in with Dave. How's it looking for Dave? He said it was a sort of bit intermittent where he was earlier, but I don't know, Dave, if perhaps you wanted to sort of just tell us about what's going on and your setup over there. It's cloudy now, unfortunately, where Dave is.
I wonder if maybe we go across to Robin's schedule. I believe that he took some images earlier on this evening, which might be quite interesting to take a look at if Robin is available.
No.
Yeah.
Robin? No.
I do have...
No.
Hi, yes, I'm here. Yeah.
Oh, there's Robin. Excellent.
I've got to start my video. Hold on. There we go. Here I am. Yeah. I took a look earlier on about this conjunction, which is of the Moon, the crescent Moon, and Saturn and Jupiter, and it was very low, I must say. Now, if Kilda could stop sharing my screen, I will attempt to share mine. That every time I try this, I click on the wrong thing, and I'm going to try and do it correct this time. Okay, here we go. Let me see which one it is. Let's try this one. That's not the one actually I was hoping to get, but it does show you a processed image of Mars, which I took earlier on. Can you see that one? The picture of Mars?
It looks the other way up from the ones we saw earlier.
Yeah, it is. You can see that sort of finger there of which is the dust storm. Now, this was taken with a much smaller telescope than the guys there were showing, and it shows that also Mars was behind a tree at the time. It was appearing through the branches, but I was quite pleased with that in terms of what it would show. What I'd like to do now is to show you the video which I took. But there's the conjunction anyway. I'll just pause it for a second because I've been let me go back a bit since you can now see it. There we go. There we are. We've got the crescent moon there, which is overexposed at the moment, and there's Jupiter and there's Saturn. And you can see that Saturn is quite a bit fainter than Jupiter, but they look quite reasonable in the sky, and they are above houses, as you can see, not the best place for observing planets and so on. But nevertheless, I then got the telescope out, and as I run this video, we'll get a close-up of the 3. There's the crescent moon, quite a large crescent. It's overexposed there, Saturn and Jupiter, and there's a bit of cloud there, so I didn't get the best image. Then I decided to get the telescope out and have a look at each image in turn, and this is a portable telescope, which you can see here. This is an 8-inch Schmidt-Cassegrain telescope, just on a portable mount. There's a rather basic laptop that I used for recording the images, and there's a little camera at the back of the telescope there. This sort of telescope is a sort of mixture between the reflector and a refracting telescope, so that condenses the length of the tube there. So I'll run this now and we have a look at some images. This was the appearance of Jupiter through that telescope. As you can see, very low down, you can just about see the bands on the belts on the planet there. Nothing very exciting. Then there's Saturn. I think that's the first live Saturn we've had this week. So I was determined to try and get an image of this. As I say, it was a cheap laptop, so it's at a quite low frame rate. And you can see quite a lot of false colour there between the blue and the red, that the one side of the other of the planet, due to the very low altitude of the planet. Then I looked at the Mars, at the moon, and you can see this is the Mare Crisium. You can see that the image is all over the place. This is what we call the astronomical seeing. It's really all of a shimmer, and that's something we have to put up with. And you've seen that on the other images as well. And finally, this was Mars, and sorry about it hopping around a bit, but you can actually see that that dust storm, which I showed you in the still image that I showed right at the end there, at the beginning. So that is to look for the conjunction. In the next night or two, the moon will be further along in the sky, as you can see there, but it's well worth looking for, and take a look through binoculars. So that's my video for you.
Thank you very much, Robin. I mean, I think it serves to remind us, although this is the week of Mars, the other planets are just absolutely as fascinating. And for me, looking at Saturn through a telescope, I mean, when you're showing people the sky, people who haven't looked through a telescope before, and Mars is great. Jupiter's got those bands; it's bigger in the sky. It looks more exciting. But Saturn is when people's jaws just drop to see those rings. And to me, Saturn looks almost three-dimensional of the planets. You can just imagine it's like a little model hanging there out in space. And if I were a public relations officer for the whole of the universe, I think I'd put Saturn up there as my #1 sky site. And of course, the moon is wonderful. We saw those craters there, and even a small telescope or a pair of binoculars will show you the moon as you haven't seen it before if you're just used to looking at it with the naked eye. So thank you very much, Robin, for showing us those extra views tonight. Les, do we have somebody else looking at Mars who can talk to us about Mars now, do you think?
Yeah, I think Dave was still having problems. Let me just, if I may, I'll just share whilst Robin just showed us that wonderful conjunction of the video. I've managed to sort of pop out with just my little, well, it's not even a DSLR, it's one of those sort of bridge cameras, but it's all in one, and I managed to shoot this evening. Again, it's the conjunction with the crescent moon, and almost some sort of hints of craters on the Terminator, and Saturn looking very sort of serene behind the clouds, and Jupiter.
Well, that's a very artistic shot, actually. I think what's happened, because the moon is behind the cloud, it hasn't saturated too much, so you can see the clear crescent shape.
And that was, we just had a nice clear spell, and that was the hint of the clouds coming, and then it all clouded over, as I mentioned right at the start. So let's just see how are we doing. I'm just going to check in with Chris. I know Chris was doing some processing. He was going to go away and do some processing. Have you had any success, Chris?
Okay, so that's the image processed from the video I took earlier on. It's still fairly fuzzy. I have sharpened it a little bit, but it wasn't standing very much in the way of sharpening. But this slightly lighter region there, if you can see the cursor, is the polar cap. And this is what we think is the dust storm coming around the edge of Mars. And it seems to be traveling along one of the valleys, which might be this line that we're getting here.
Yeah, that's very clear. In Kielder, we've just seen, you could see that in the live images, but it's sharpened up a lot here.
It's sharpened up a little bit. Frankly, that's not a good image of Mars, I would say, but...
Just keep on trying. I was going to say, we've had a message in from Agapius in Cyprus, who's been with us all week looking up at Mars, and he says, "Great image, Chris. The dust storm has extended a great deal since yesterday." I think that's one of the exciting things about the observing sessions we've been doing this week, that we are really showing you Mars as it changes. So this is the latest news about Mars. Tonight we've seen that dust storm extending. So you out there looking at this are the first to know.
There, can you see that?
Wow. Yeah.
So that was taken somewhat earlier. That was taken in September.
Mm-hmm.
But that's probably one of the best images of Mars I've taken this apparition. And that does show a reasonable amount of detail. You've got some structure in the south polar cap there. And this dark line here running up towards the center is actually the Valles Marineris, which is where that dust storm is channeling along at the moment. So we are currently seeing more on what is the left-hand side of Mars in this image. But gradually, as Mars rotates, as we see it, these areas will come into view more and more often, which is what happened, is why we're seeing the dust storm now, I think, on that side. So that, I would say, is what Mars ought to look like through a 8 or 10-inch telescope if you process an image properly. The one I've got this evening really was not a very good example of that, but that's the conditions we have. So
just goes to show it's not just a matter of the clouds being out of the sky, but actually the air currents and the jet stream as well. Well, thank you.
Well, the jet stream on this occasion, on the September, I know was very, very low indeed. There was almost nothing there, so the air was very steady.
That's fantastic.
And that really shows you the difference that it makes when you have a steady atmosphere rather than what we have tonight.
Well, thank you for finding out and sharing it with us. I think Robin has some more pictures as well, if it's possible to go back to Robin, if you have some for us.
About that, can you see pictures of Mars?
Absolutely, yeah. And
right.
Beautiful detail.
Good. Okay, not taken by me. These were taken by Agapios in Nicosia in Cyprus.
Congratulations, Agapios.
They are superb. And he's got a 14-inch, two different telescopes, his own 9.25-inch Schmidt-Cassegrain. That's a slightly more grown-up version of the one I showed you earlier on. And you saw my picture of Mars, which is pretty crummy. But he's got an absolutely brilliant picture of Mars there with a slightly larger aperture of the same sort of telescope. And look here, you can notice that around here, there's not much to be seen apart in terms of brightness. Look at the picture which that was on the first night of National Astronomy Week. Just a couple of nights later, look what's happened. You've got these fingers of dust which have spread out of this area, or presumably all spreading over the Mare Serenum there. And that was the first indication we had that was a dust storm in progress. And the following night, just on the 17th, this is what it showed on his image. And tonight we see that dust storm seems to have spread it in the same direction. It's now expanding a bit further. Our pictures aren't as good as the ones that Agapios has got, but that shows you what is going on in this dust storm. And absolutely, I've never seen a dust storm in the same way spread so in that way. Sometimes you get a planet-wide dust storm, and I think we had pictures of those earlier on, and it just covers the whole planet. But there is also one, I believe, on the other side of the planet as well. So anyway, that's the dust storm in progress, and we've been watching it live on National Astronomy Week.
I think we've been very lucky, Robin, to have the National Astronomy Week this week, because who knows, next week maybe the dust storm will have blotted out the whole of Mars, and it won't just be a matter of weather on the Earth. It'll be Mars covering itself up from view. So
that's right. We've got clouds at both ends to worry about.
Well, we're coming up to 8 o'clock now, Les. I think it's probably beginning time to wrap it up for tonight. It's been a very exciting session, I think.
Absolutely, yeah. Some fantastic images and views. We managed to sort of dodge the clouds mainly. We've been all around the country pretty much as well. So great thanks to the guys up in Kilda and to Dave. I know Dave struggled with the clouds tonight, but thanks for joining us, and Chris, Robin, and I know Agapios is out there. Probably out there this very evening. So thanks very much for supporting us all this week. And I think you're probably there's more to come as well. So and it's not over yet, is it? We've got another how many more days? A couple of days to go, I think.
Up until Sunday. So thank you very much indeed, Les, for co-hosting this session with me as well. It's been great to have your views. And I'd like to thank Sanjeev and John from our earlier part of this evening. And as Les has been saying, tune in again. And tomorrow we've got a very exciting day. We're talking about careers in astronomy, how you or your children can become a professional astronomer or planetary scientist, perhaps studying Mars or one of the other planets, or a space engineer building those incredibly sophisticated spacecraft, the robots and manned missions that we've been looking at earlier on. What I'd like to do finally is to ask everybody who's still on the show tonight to actually switch on your cameras, and then we'll all say goodbye. If we go to a group view, is everybody there?
Everyone's all on a gallery.
Okay, everybody's there. So I'd like to say thank you very much for joining us for another night of National Astronomy Week. Hope to see you again very soon. Good night and clear skies.
Bye. Bye.